All right, guys, we're on to lesson number 6, which is all about multiplying binomials and trinomials together. Now, binomials, again, we talked about earlier. Bi means 2, so these are 2-term polynomials. All right. Trinomials, tri means 3, so this is a 3-term polynomial. So we're multiplying a 2-term polynomial times a 3-term polynomial. Now, in order to do this, all right, we use the principle of distribution, or the property of distribution. We're going to multiply each term, right, from the binomial, we're going to multiply each term of the binomial individually to each term of the trinomial. So we're going to multiply the binomial times the trinomial, but we're going to do it one at a time. So what we're really going to do is we're going to start with the first term, and we're going to distribute that to everything in the trinomial, so everything in the trinomial. Then we'll use this second term of the binomial, and we'll distribute that to everything in the trinomial. Now, as we do that, we're going to use that column method like we used with FOIL, because that's going to help us with combining our like terms and getting into standard form. Now, after you've done that distribution and you've lined them up in the columns, then you need to make sure you combine your like terms appropriately. And then again, reminder, make sure it's in standard form. All right, so let's take a look at example A here. So example A says the binomial of x plus 5 times the trinomial of x squared minus 3x minus 2. So the first thing I'm going to do is I'm going to distribute this positive x right here to every term in the trinomial. So x times x squared, well, again, those are the same base, so I add the exponent. So 1 plus 2 is 3, so I've got x to the third power. Then I'm going to do it to the next term, so x times negative 3x squared. Well, because there's no coefficient on the front of that, it's really just 1, and 1 times negative 3 is negative 3. And then x times x, well, remember, exponents are 1, so that makes it x squared. So we're still using that product of property rule that we've been talking about for a while. Then I need to do the first term times the last term of the trinomial. So x times negative 2, or 1x times negative 2. Well, 1 times negative 2 is negative 2, and then x comes down with it. So that's the distribution of the first term of the binomial to everyone in the trinomial. Now, when we do the second term, that should be the second line when we're doing our columns, and we should end up starting one spot over. So I shouldn't have anything underneath x to the third. But let's see if that plays out that way. So we take the second term, which is positive 5, and we distribute it to every term in the trinomial. So positive 5 times x squared is just positive 5x squared. Are these both x squared terms? Yes, they are, so it's working. So then we do positive 5 times negative 3x. Well, positive 5 times negative 3 is negative 15, and then the x comes down with it, so negative 15x. And then positive 5 times negative 2, well, that is negative 10. Now, if I've lined everything up correctly, I should have the same like terms lined up on top of each other, and I can combine and should be in standard form at the end. So x to the third, nothing to combine that with, so that comes down. So that's x to the third. Negative 3x squared plus 5x squared, well, negative 3 plus 5 is positive 2. These are x squared type of terms, so that comes down. Negative 2x minus 15x, well, negative 2 minus 15 is negative 17. The x is the type of term, so negative 17x. And then minus 10, nothing to combine that with, so that comes down as well. So I've, at this point, got x to the third plus 2x squared minus 17x minus 10. Is that in standard form? Yes, it is, so that is my final answer. All right, well, let's take a look at example B now and walk through that one together. So again, first thing I do is take the first term of the binomial and distribute it to each term individually of the trinomial. So x times x squared, well, that again, exponent of 1, so that would be x to the third. Then x times negative 4x squared. Well, again, remembering that there is a 1 out in front of here. 1 times negative 4 is negative 4. X times x is x squared. Then the last term, so x times negative 4 is just negative 4x. Then I need to do the last term of the binomial times every one term in the trinomial. And so I'm going to do that below, and that should line up my terms. So negative 3 times x squared is negative 3x squared. Negative 3 times negative 4x, well, negative 3 times negative 4 is positive 12. Bring the x down, so positive 12x. And then negative 3 times negative 4 is, again, positive 12. Now, my x squared terms are lined up. My x's are lined up. So I am in correct lineup order. So now I need to combine my like terms. So x to the third, nothing to combine it with, so bring it down. So that's x to the third. Negative 4x squared minus 3x squared. Well, negative 4 minus 3 is negative 7, and they are x squared kind of terms. Negative 4x plus 12x. Well, negative 4 plus 12 is positive 8. And then they are x type of terms. And then positive 12, nothing to combine that with, so bring it down as well. So at this point, I'm at x to the third minus 7x squared plus 8x plus 12. Is that in standard form? Yes, it is. So that is my final answer. All right, well, I'd encourage you to try example C on your own, then check your answer with mine. So again, first thing you want to do, you distribute the first term of the binomial to each term individually of the trinomial. So x times x squared is x to the third. X times positive 5x is positive 5x squared. And x times positive 8 is positive 8x. So I've done the first term. Now I need to do the second term of the trinomial. So positive 1 times x squared is positive 1x squared. Positive 1 times positive 5x is positive 5x. And positive 1 times positive 8 is positive 8. So now I need to line up my terms, make sure they're good. X squareds, x's, very good. So typically what you've probably noticed is you don't have anything underneath your first term and your last term. That happened the same way when we were doing the FOIL method with the binomials. That should always happen if you're doing this correctly. So then x to the third, nothing to combine it with, so bring it down. 5x squared and positive 1x squared makes positive 6. 5 plus 1 is 6, and they are x squared kind of terms. Positive 8x and positive 5x, well, positive 8 and positive 5 make positive 13, and they are x type of terms. And then positive 8, nothing to combine it with, so bring it down. So x to the third plus 6x squared plus 13x plus 8 is where I have it currently. Is that in standard form? Yes, it is. So that is my final answer. All right, well, I'd encourage you to try example D on your own here and then check your answer with mine. So again, first thing we do, first term of the binomial times each term of the trinomial. So n times n squared is n to the third. Because again, we're using that product of powers rule. So we are combining the exponents by adding them. So then first term times the second term. So n times negative 2n. Well, again, that's like 1n. So 1 times negative 2 is negative 2. And n times n is n squared. Then we've got n times positive 4. Well, that is positive 4n. So first terms are done. Now I need to do the second term. So negative 3 times n squared is negative 3n squared. Negative 3 times negative 2n. Well, negative 3 times negative 2 is positive 6. And then bring down the n. And then negative 3 times positive 4 is negative 12. Put my line underneath. Combine my like terms. So n to the third, nothing to combine it with. Negative 2n squared, negative 3n squared. Negative 2 minus 3 is negative 5. And they are n squared kind of terms. Positive 4n and positive 6n, Positive 4 plus 6 is positive 10. And again, bring the n down. And then minus 12, nothing to combine that with, so bring it down as well. So at this point, we're at n to the third minus 5n squared plus 10n minus 12. We want to check and make sure that that is in standard form, which it is. So we have finished that problem as well. N to the third minus 5n squared plus 10n minus 12 is our final answer. All right, well, if you have any additional questions on how this stuff works, please feel free to reach out. Otherwise, you should have what you need to complete worksheet number 1 from chapter 7.